Okay, moving now towards the first link paper, which is about TinyOS, and this paper was published by these two authors. TinyOS, or Tiny Operating System for Sensor Network paper, was presented about a flexible application-specific OS for sensor networks. This was an old paper, and those time the author or the publisher was imagining a lot of things which was they were predicting that will happen because of these tiny devices popping up in the corporate world. So they call it low power nodes, and they are saying that each will execute concurrent reactive program. And this operating system, we can call it as a framework, not an operating system. An application framework was developed to support these sensor networks. The paper explain about the fine-grained component within the execution model. The tiny operating system meet these challenges. They are providing qualitative and quantitative evaluation of the system, and there were many applications which was fit within the 16 kilobyte of memory, and the core operating system was just 400 byte, and it was a low power operation. So this tiny operating system, as I read through the paper, is talking about the primary goal to enable innovative solution to the system challenge presented by the networks of resource constrained devices that interact with the physical world. So this tiny operating system paper support wide range of hardware platform. There were fewer than 400 byte operating system running built on these sensors, and there is an extremely low power operation, provide great deal of flexibility in power management, and we call it as also as a programming framework for these embedded system in the tiny operating system or tiny OS. Is a critical The critical aspect of that tiny OS is the design, the network architecture. So the core tiny operating system communicate abstraction it was based on the active messages AM, a small packet associated with 1 byte handler ID. So this was the evolution of the operating system for these IoT devices. Then at the final conclusion, the paper discuss about the three application: the environmental monitoring, the object tracking, and the declarative query processor. So the operating system component model are four key requirement: limited resource, reactive concurrency, flexibility, and low power. The second paper selected from the base paper was the challenges, the opportunity, and the solution. So this is Internet of Things OS system management, and there is a explanation here that I explained previously, that IoT is connecting all sort of environment, enable cities, ships, aeroplanes, cranes, factories, shoppers, corporate, e-commerce, mobile devices, and edge-to-edge IoT devices and data centers. So uh, the paper abstract I have pasted here is that they are saying that the IoT are rapidly growing and contributing drastically to improve the quality of life, QoL. There's a big growth happening right now during the publication of this paper. The advancement of the operating system in the IoT domain support newly developed hardware with the recent standard and techniques in all the communication layers. So there are variety of IoT operating system available for demand to support the different hardware, different manufacturer, protocol functionalities, heterogeneous development scenarios, intelligent to self-adapt according to the network condition. So this paper presented the IoT operating system options and available models of operation which explained in the commentary that they explored TinyOS, ContikiOS, Roit, and Zephyr. So these are the operating systems that are happening in the IoT domain, and these OSs are basically usually embedded within the devices to work under the constraint of limited memory size and processing power. So this was the paper one, link paper. And then the commentary is also explaining about that key driver for the fourth industrial revolution that we are talking about, the integration of digital, physical, and biological system. The operating system foundational layer up, up which IoT device can communicate with one another. So the key area of IoT operating system is to provide layers of communication protocol and network protocol and data communication capabilities. Those operating system for IoT usually perform the basic functions of a computer within an internet connected devices. As I was saying, that IoT is the next thing after the PC revolution, after the mobile smartphone evolution, and now we are in the world of IoT devices, billions of devices connecting to each other. So the second paper I choose, the link paper, is the Enhanced Software Framework for Improving QoS in IoT. The paper is explaining a little bit about the quality of service in the IoT domain. So now we are moving towards the quality assurance of an IoT device's communication, data, connectivity, and now we have the IoT layer for the trains, planes, hospitals, schools, agriculture environment, and those are connected to the micro data center of fog layer, and these fog layers are connecting to the main cloud layer of data center. In this paper, the publisher is creating a relation between IoT and AI and the subcomponent with the emerging technologies for our daily life, making our daily life easy. But when we are talking about life easiness, we have to care about the quality of services, which plays important role. And now in the QA, quality of service dependency note, we see that the increment nodes increase is hampering the quality of service. This increasing number of nodes generating increased number of requests to IoT servers. So an enhanced framework required or needed to make sure the QoS, quality of service, in the IoT application. So this paper did a study using the MATLAB for an simulation implementation of the framework, and they found different results on reducing the number of connected devices as uh, as per need. So the on demand basis, if we generate the request on demand basis versus a static increase, that can hamper the quality of service. But to change the scenario to a dynamic situation, they saw that there is an improvement of 5 to 10% on packet loss, and up to 6% and 4% latency benefit. So this paper discuss in the abstract about the overall plan for the software framework, and then in the commentary I explained here how they did that, the simulation, and what are the benefit and what the outcome they found, the reduction of packet loss, throughput, and latency. I'm a little bit going fast here. All is written over here in the commentary about the reduction of the 5 to 10% throughput, and also the average packet loss decreased by the 3 to 6%. The third paper is talking about the QoS aware IoT placement mechanism in fog computing. So fog computing is an architecture that uses edge devices to carry out a substantial amount of computation, storage, communication. So it's sort of cloud on the edge computing environment or subsystem of a cloud. So we call it a fog computing. It facilitates the operation of computing, storage, and network services and devices on the computing data centers. So in this paper, the author explained about the quality of human life has significantly increased by the usage of IoT. So the fog computing play a major role in overcoming the limitation of cloud-based networks, supporting the the communication, data transfer, response system, and also the focus was to increase the QoS in terms of low energy consumption and fast response. So this paper referred to fog service placement problem, which call it FSP, and this FSP is proposed to have a QoS aware IoT service placement. They are using different type of algorithm which they to prove effectiveness, and in those are called open source development model algorithm to deploy the IoT service on the fog nodes called FSP ODMA. So this FSP ODMA is using the service cost, energy consumption, and response time latency and fog resource utilization to find the optimal IoT service placement plan. So this is the three-layer concept computational framework, cloud, fog, IoT, three-layer. There is a cloud, then there is a fog, and then there is an IoT. So it's a layered based environment where each layer can be looked at and can be enhanced its service by handling this modular layer environment network. So the simulation result obtained by the MATLAB increases the resource usage and service acceptance ratio, reducing the service delay and energy consumption. The commentary explained over here that there are zettabytes worldwide in zettabytes number of devices equal to the 1 zettabyte is equal to 1 trillion gigabyte. So according to the estimate, there are 13.6 zettabyte in 2019, and now it's expected by the next year to be 80 zettabyte of devices connected. So this huge amount of data poses challenges for data management, security, privacy, and analytics. Cloud computing provide computing services such as storage, processing, and this is what the paper is discussing. The link paper is about the quality of services. So this is an example of environment where there are three layers. So there is a cloud layer, and then there is an edge layer. Between the cloud and edge is the fog layer, and then there is a third layer, the IoT sensor. So this bottom layer is the IoT sensor layer, and the top is the cloud, and in between is the fog layer, which we call edge layer. So the paper is talking about the FPS, the fog placement service problem, and this is where the energy aware placement is required. So the FSPCN and the ODMA algorithm is used to identify the enhancement in the quality of service. The fourth paper is again talking about the quality enhancement services on the operating IoT environment. So it's a lightweight location aware fog framework, LAFF, in the QoS in IoT paradigm. So here is a graphical example of driverless cars communicating with the network through the WiMAX, open access network or the SDN controller, and then it's going to the cloud area. And also there are mobile, there are security cameras. So the abstract talk about, as per the previous paper, the leverage cloud fog computing and the cloud computing, data congestion area processing locally in the distributed decentralized way on the fog edge, and this fog framework precisely satisfy the quality of services. So there are some numbers that they have proposed in the paper about the improvement in the quality of service. And my commentary is also about this paper that they are focusing on the latency sensitive application. There are trillions of IoT devices which is increasing the demand for the application. So this low latency application media streaming players need react quickly to incoming media packets, and that's they propose in the paper about the lightweight location aware fog framework, which I call it dynamically responding or requirement on demand basis. Not so it's not like a push network, but it's a pull network which reducing the services required. So the location aware algorithm is involved by user registration on foghat. Again, this algorithm works only with the star topology, and there are resource sharing among the fog nodes. That the resource can on the operating system are shared by task scheduling, response time, and so the LAFF improve quality of service. The last paper is about the healthcare industry, where the healthcare industry is getting a lot of benefit on the IoT. So we are talking about gray filter convolutional uh, uh, technology. So the relation between technology and healthcare society is rises due to IoT networking capability. So deep neural networks, so public embracement of medical wearable, all these things belong to the IoT device network. And this is where we are talking about how to handle manage. So there is a smart healthcare method called gray filter Bayesian convolution neural network, GFP CNN. This GFBCN based approach, or we call it a holistic AI driven IoT health architecture, is enhancing the quality of service parameters like time, overhead, reduce higher rate of accuracy. So this is the proposed GFB CNN method, or architecture, which is showing the result in minimal time, overhead increase, and accurately evaluate medical data, because medical data needs to be accurate and timely delivered. So the commentary continue on this, and we talk about more personalized disease management and prevention approaches in the healthcare industry, monitoring the patient remotely to reduce healthcare costs by the QoS. So this paper, Bayesian logistic function applied and proposed with the gray filter Bayesian convolution network with gray filtering feature for reducing computation overhead. So the method proposed two spaces. One is the physical space and the other is cyberspace. So it enhances the accuracy rate of data analysis. In the end, the network can be applied to tasks like image classification, image super resolution, like X-rays, and the generative adversarial in the disease or the pandemic. There are some benefit that was generated during the corona time with this approach. So there are two algorithms, battery recovery based algorithm and the joint energy harvesting duty cycle optimized based JEDO algorithm designed to manage the battery and energy in significant matter. So the prime objective of the proposed systems is to minimize the communication overhead and response time to enhance the accuracy of medical data analysis. So this was the conclusion in the GFP CNN method. But however, sometime it's failed to consider medical data analysis with security and privacy. So in the future, the proposed method further extend for secure medical data analysis by using a new security protocol. Thank you very much. And this was my presentation on IoT devices, the operating system, the communication, the quality of service, and the application with the fog, lightweight, for location-based fog computing. Thank you very much.